My name is Damien Edwards. As I was introduced, I'm a program manager at Microsoft on the ASP.NET team. I look after a couple of areas, the core ASP.NET runtime and web forms that sits on top of it, so the bits that ship in .NET. I also look after some of our old Ajax stuff, the Ajax CDN, and various other bits and pieces. But today I'm here to talk to you about something completely different. Today I'm here to talk to you about SignalR. So SignalR started life as a moonlighting project, as we call them at Microsoft. It's me and another guy on the ASP.NET team, David Fowler, who was actually a developer on the ASP.NET team. I am just a PM on the ASP.NET team. But for SignalR, I am a developer as well, so I feel good about that. SignalR is a persistent connection abstraction library for .NET. Who's heard of Socket.io for Node? Okay, bunch of people. Who's heard of Now.js for Node? Less people. Okay, so SignalR is kind of like a combination of Socket.io and Now.js, but for .NET developers. And so rather than continuing to talk about it, I'm just going to build something now so you can have a look at what this looks like. So I'm using Visual Studio 11, the beta here. I'm going to say a new project, and I'm going to start with an empty web application. And then from this web application, I'm going to go into NuGet, and I'm going to pull in a package which is a pre-canned SignalR sample. So I'm just going to search for SignalR.sample. Here it is. I'm going to hit install. And through the magic of NuGet, that's going to pull in not just obviously the sample, but all of its dependencies. So we can see here, a bunch of stuff is now being referenced. I've got some SignalR stuff in here and various bits and pieces. If I look at my packages config, all this stuff was just brought in via NuGet for me, which is wonderful. There's a folder here called SignalR.sample. And it's a stock ticker. So one of the quintessential sort of canonical apps that people build when they want to do anything that's kind of real time, this idea of a persistent connection. So now I've done that, I'm just going to run it up, Control F5 to do so. And so here's my stock ticker running on one screen. I'm just going to pull this off, pin that over there. I'm going to create another window over here, pin that to the right and paste that in. So I've got two windows now, in this case Chrome, running my stock ticker. I'm going to hit Open Market in one, and you can see that they both are now running this stock ticker. And all being well, we'll start seeing some stock changes come through any moment now. These aren't real, obviously. This is all just made up in this sample, but it gives you an indication of the type of thing that SignalR lets you build fairly easily. So that's great for a pre-canned sample. Well, let's build something from scratch that's a little bit different. So I'm going to add a new folder here. I'm going to call it Move Shape. So you can probably start to guess what it is that we're going to build. I'm going to start out with the server-side code. And I'm going to build a class. I'm going to create a class called the MoveShape Hub. Now, in SignalR, we'll talk a little bit more about the various layers of abstraction available to you as a developer in SignalR, but we're going to start out at our highest level, which is hubs. So I'm going to derive from a SignalR hub. I'm going to decorate this with an attribute that lets me control the name that this appears to as clients. I'm going to add a method to this hub that the clients can call. So the clients in this case are going to be the web browser, and this is my server. So I'm going to go ahead and add a method called MoveShape, and it's going to take in an X position and a Y position. And then immediately when that happens, I want to broadcast out to all currently connected clients that someone has moved this shape. So I'm going to say clients.shapeMoved, and I'm going to pass in the current connection ID. So this is the person who moved to the shape, so the connection ID of the person who just moved the shape, and the X and the Y coordinates. So that's my server-side code done. Shape move is dynamic. You can see here Visual Studio is telling me this is a dynamic expression. So rather than me sending a message over a connection, which I then have to deal with on the client to do my own dispatching, decode the message, and that type of thing, with SignalR, this high-level abstraction, I'm just calling a method on the client. Now, the client might be JavaScript, it might be .NET, it might be an iOS device. We'll talk a little bit more about that later. But in this case, I'm just saying, for all the clients, go ahead and invoke the shapeMoved function and pass in these parameters. So let's go ahead and write our client. So in this case, it is JavaScript. So let's create a JavaScript file, MoveShape. Who's installed Visual Studio 11 beta, by the way? Who's had a good play with the JavaScript editor in this version? Who thinks it is vastly superior to the one that was in the previous version of Visual Studio? Yes, it is really, really good. Okay, so let me drag in a reference to jQuery and a reference to SignalR here. And then I'm just going to do some pretty standard sort of jQuery stuff. I'm going to add a document load handler. In here, I'm going to say var hub is equal to, now I'm going to start using the SignalR stuff. So SignalR in browsers is exposed as a jQuery plugin. And I get to that jQuery plugin from $.connection. Whoops, that's not what I wanted to do. Yes, I am running Windows 8. So connection.moveShape is what I called that hub. So if we go back here, remember I said hub name is moveShape, and that's what it's going to be exposed as. So then I want to also just create a reference to a DOM element that I'm going to look up again using the wonderful jQuery. So there's my variables that I need. Second thing I'm going to do is add that method to my client-side hub that I want to invoke from the server. So if we go back to my server code, we're going to be invoking a method called shapeMoved and passing in 3 parameters. So let's do that. I'm going to use $.extend, one of my favorite methods in jQuery, and I'm going to pass in an object literal. On this literal, I'm going to add shapeMoved as a function that takes a connection ID and a coordinates. And then the first thing I'm going to do is check, hey, make sure this wasn't me who just moved the shape. Because the last thing I want to do is move the shape on the screen, send it to the server, and then have the server tell me to move the shape again. So I'm just going to say if $.connection.hub, which is the underlying hub connection.id, is not equal to the past connection ID from this move event, then go ahead and move the shape on the screen. So I'm going to say shape.css. Again, jQuery makes this just so easy for us. Left is X, and top is Y. So the last thing I need to do, other than fix my formatting, because that's going to annoy me, is go ahead and start the underlying connection that this hub communication is going to happen on. And then once that start has finished, I know the connection is up and running, go ahead and enable the client-side behavior that lets people move the shape around the screen. I don't want them to be able to move the shape until the connection is actually up and running. So I'm going to say $.connection.hub.start. And then when that's done, I want to go ahead and call this callback. So that's a jQuery deferred. If anyone's who's used jQuery deferred objects before? Okay, so if you call $Ajax or the CSS animations now, anything that's asynchronous in jQuery will potentially return you a deferred or a promise object. So you can just call done on that. We're using that same paradigm here in SignalR. So once the connection is up and running, I'm going to go ahead on my shape and invoke the draggable behavior, which is in jQuery UI, which is a great reminder to me to actually go and install jQuery UI now. So let's go back to NuGet, quickly find jQuery UI. There we go. So jQuery UI is now installed. If I wanted to, I could drag this in just so I could get some IntelliSense. And then what I'm going to do is say, well, when the drag event happens on this draggable behavior, I want to go ahead and call the server and let them know that this shape just moved. So I do that by using my hub. Now if we go back here, the method I need to call is moveShape. So hub.moveShape. Now we do some case conversion because this is the JavaScript client when we generate the proxy, and we'll talk a little bit about that in a moment. And I need to pass in the current X and Y. So in this case, it's going to be this.offset left. This refers to the DOM element that just raises the event. In this case, it's the drag event given to me by jQuery UI. And this.offset top or 0 if that's not set. Okay, so that should be my client-side code done and working if I haven't made any mistakes. So let's go in now and add some UI. So I'm going to create a new HTML page. We'll just call this index.html. Let's drag in the world of JavaScript here. So I'm going to need those two. I'm going to need that one, and I'm going to need that one. Let me drag those into my index file like so. And I need one more reference to make the SignalR magic kind of happen. So I'm going to grab those, and it's not a real file. So what I'm going to do now is add a reference to a known endpoint that only exists in SignalR applications. And what that endpoint does is generate a JavaScript proxy on the fly based on the hubs that you've defined in your C# code. So to do that, I'm going to come in here and say /SignalR/hubs with an S. Let's add the UI. So I'm going to have a div ID equals shape. Beautiful. And then I'm going to add some style so we can actually see this thing. So we'll say shape. We'll do a width, not windows, no, widows, whatever that is, 100 pixels. Height, 100 pixels. And we'll do a background. Let's do a background color. I love this new CSS color picker that's in VS 11. Let me use that one here. And I'll do a cursor maybe so people can see that they can move it of move. All right, let's build that, make sure it runs. Okay, let's run this up. I don't seem to have any errors so far. That's a good start. It's always a bit of a danger when you're doing live coding on stage. Let me grab this URL, snap this one to the right, paste that in and do that. Now, hopefully when I pick this up, the shape on the other screen moves. Okay, thank you. So how long was that? I don't know, 6 minutes. And we've built an application using the SignalR Hubs abstraction that lets two browsers talk to each other in what kind of looks like a peer-to-peer manner. Now, this is not the most efficient way to do this type of application. Please don't go away now and start listening to every single mass move event and doing mass broadcast to thousands of connections, because that will not scale very well. But it's a great demonstration of the type of programming you can do with this API. So let's jump back for a moment, talk a little about how this is actually working under the covers. Okay, so we have two levels of API in SignalR. What I showed you here is our higher level API, which we call hubs. And you can see to do that, I just derive from a class called hub, and then that gives me all these intrinsics that I can use to accept invocations from the client. So this is much more about doing remote procedure calls. So it's more like RPC style programming rather than messaging. So this is a RPC from the client when it calls move shape, and then I do RPC from the server to the client by doing clients.shapeMoved, in which case it's a mass broadcast RPC. We have a lower level API as well called the connection API. So if you don't want to use this invocation model and you'd rather just send messages back and forth between the client and the server, you can absolutely do that. The messages will just get serialized as JSON. We have our own sort of wrappers that go around your message payload so that the SignalR client in the browser and the SignalR server knows how to push messages back and forward. Incidentally, the hub level API is built on top of the connection level API. So we do stack these things up in a nice modular fashion. If you don't like something that we do with the hubs, you could potentially build your own abstraction on top of our connection level API and do whatever it is that you want to do. Perhaps you want to be more pub subby, you want to use strings instead of using method calls, etc., etc. Maybe you don't like using dynamic in here and you want something a little more strongly typed. You're free to build that on top of our connection level API. If we go back into the browser here, let me run this up again. And we'll just have a look at the type of code that's running here. So I'm just going to bring up my page inspector in here. And let's go and have a look at the network tab. And I'm going to go ahead and just move some stuff around so I get some traffic in here. So we can see, in this case, as I was moving the stuff around, a whole bunch of send operations happen. And when they're called send operations because they have the word send in them. We try to make it a little bit easier to sort of debug this stuff. So what you're probably wondering is, well, okay, what underlying transport or technology is SignalR using to actually get these messages back and forth to the server? Well, the answer is a little complicated. So like Socket.io, we have a fallback mechanism. So we have a number of underlying transports that we support that give this, illusion of a persistent connection between the client and the server. Because obviously HTTP is not a persistent connection technology, or it wasn't at least until a few weeks ago when the WebSocket standard was ratified. Now, incidentally, WebSockets is supported by SignalR, or at least it will be. It was supported in the previous release. We broke it with this release, and we'll fix it in the next one. It's still very much in alpha state at the moment. But WebSockets is very much our highest fidelity underlying transport technology. And so to get WebSockets working on ASP.NET, you need to be running ASP.NET 4.5, and you need to be running it on Windows 8 Server. So I know it's a whole bunch of requirements needed in order to use WebSockets, which is one of the reasons SignalR exists. Because while WebSockets is fantastic, the world just isn't really ready for it yet. There are a lot of people using browsers that don't support WebSockets. WebSockets really changes the intrinsics of how HTTP traffic behaves. So we have a lot of infrastructure set up on the internet to do with load balancers and front edge caching and routers and stateful packet inspection, all this type of stuff that just hasn't been updated for WebSockets yet. A lot of it has, a lot of it hasn't. So in the meantime, we have these other technologies that we can use. So let's have a look quickly at the source code, and I will show you some examples of these clients. So I'm going to jump into, this is the SignalR source code. This is our actual solution here. Let me jump into the jQuery, the SignalR jQuery plugin file, and I'm going to scroll down here to this property here called SignalR.transports. And we'll just collapse, they didn't support collapsing, that's a shame. So we have WebSockets at the front, which I talked about. Underneath that, we have a technology called server-sent events. Anyone heard of server-sent events? Okay, otherwise known as event source sometimes. So server-sent events is an HTTP streaming technology that's been around since about 2006, I want to say. I think the Opera group originally put this into Opera. It's a bitch of a standard to implement, let me tell you. The standard itself is actually really, really simplistic. If you can go and read the spec, it's up on W3C. But the implementation is a little bit varying across browsers, and some of the features that server-sent events sort of has don't really work that well in the real world. Things like it has inbuilt reconnect logic, so that if you make a connection to the server and the connection is truncated in somehow, then the server-sent events object in the client will attempt to reconnect. The problem is you can't affect that request. The request is always a GET request. You can't change the query string. You can't add any headers. You can't add any cookies. And so in the situation where you need to be able to send renewed information every time the request is sent up, you can't use the reconnect logic in server-sent events. So in our case, we couldn't. We had to sort of polyfill reconnect on top of that. So server-sent events is great. It's supported by, for the things that it does do well, it's supported by Opera, Safari, Chrome, and Firefox, basically everything but IE. And for those browsers, this is what SignalR will use. Now, incidentally, the order that these appear in this object here, this transport object, is by default the order in which these transports will be attempted to be used by the client until one of them succeeds. So again, it's a fallback algorithm that we use. So server-sent events is that. The next one we have is called forever frame. Again, who's heard of the technique of forever frame streaming? Okay, a couple of people. This is the idea of creating a hidden iframe in your page, which makes a request to an endpoint on your server that never ends. All that request does, or the server does, is send down script blocks, and luckily browsers will execute script blocks as they arrive in the frame. And so you can effectively stream information to the page by streaming it into the iframe as a script block, and then having that script block sort of push the information back into the parent page, which of course we all know how to do as long as the domains are synchronized. So this is the default transport that we'll use on IE. IE supports this very, very well. Obviously it's a hack, but people have been using this hack for many, many years now, and it does work very, very well. Again, we have retry logic, we have timeout. If you get to this transport and it doesn't connect within 3 seconds, we fall through to the last transport, which is the one that just works everywhere, which is AJAX long polling. So again, who's heard of AJAX long polling? Okay, a lot more people have heard of this. So the idea of AJAX long polling is that with a normal poll, I have some set interval that my client will call out to the server and say, is there data yet? Is there more data yet? Is there some data now? How about now? And it'll just keep doing that and then getting data if there is data to be served. And of course, the balance there is figuring out what should that interval be in order to get me the closest solution to real time that's required for my application without bombarding my server with lots and lots and lots of requests that ultimately do nothing. And so long polling is a little bit of a twist. You make the request, an AJAX request, but rather than returning if there is no data, the request just stays there. And the request will stay open until such time that the server says, now I have data for you, and then that AJAX long poll will return. It's processed on the client, and then immediately a new long poll is sent out to the server with some type of token indicating to the server, this is the last piece of data I retrieved, so that it knows whether there's any data since that point in time. So long polling is a very well-established paradigm. It does work very, very well. The latency is a little bit higher, of course, because there are lots of periods, if you have a lot of data going over, where there is actually no underlying connection. Because every time there is data being sent, we return the long poll, we process the data in the browser, and then we make another connection again. So there's a whole period of time there where you're not connected, which requires you to do some type of message buffering on the server. Because if you want to broadcast to clients, and some of them are in the process of re-establishing that long poll connection, they're going to miss that message until such time they're connected again. So you need to be able to then give them that message as soon as they've reconnected. So SignalR does do message buffering in the server for you by default, so that any of these underlying transports, when they're in their reconnect state, will get those messages when the connection finally does reconnect. So they're the 4 transports that we support out of the box. And of course, if there are any other transports that you wanted to support, you could easily add them here. The APIs allow you to, rather than use this default transports object, you can just pass in an object that looks like one of these, as long as it has the right members, and we will use that as the transport. So if you wanted to use Flash sockets or Silverlight sockets or something like that, I know Socket.io supports some of those. As long as you can implement the server-side implementation of that, you're happy to, we're certainly happy to have that work as well. Okay, so that's the underlying transport technology. What about multiple clients? So I showed you how to do this with a web client. So let's jump to a slightly more finished version of this demo now. So this is Move Shape as we just saw it, but I've done a little bit more work on it, and I've changed a few of the ways I do some things to better support multiple clients. So let's run this one up. Find where my window went. Here it is. I think that's the right one. Let's go to Move Shape here. So you can see it's the same thing. if I pin this one over here, you can see I've got an extra number showing up on the right-hand side. And that just went up to 2, and when I move around, it moves. So what I'm showing the top right-hand corner is the number of connections that are currently connected to the server. SignalR will do connection tracking for you. So we will raise an event. When I say tracking, we will give you an event when a connect happens. We will give you an event when a disconnect happens. And we will give you an event when a reconnect happens. Now, a reconnect, as I said, is when the transport goes away for whatever reason and then has to reconnect but uses the same connection ID. Now, by giving you those 3 events, it gives you the ability to now track how many connections you have on your box. What we do not do is give you a collection of connections that you can enumerate over to do stuff. That is not how SignalR works. And the reason that we don't do that is because if we did that, we couldn't scale it out. So SignalR does not intrinsically store any state about the connections that are connected to the server. It's very much internally a pub-sub model. Every connection establishes a channel with a unique ID that represents that connection. And if you want to send something to that connection, you need to know its connection ID because it's the only thing listening on that channel. There are also group channels. So the endpoint that you created, that hub that I wrote before, that itself becomes a channel that multiple people can listen to on the, when we're talking about the underlying mechanism here. And then when you say, call this method on all my clients, what's happening is that we're doing a broadcast on the channel that represents that hub so that all the clients now get that message. And then we do all the dispatching for you to call that method. Okay, so now I'm using a web client. What about something a little bit different? So let me go back to this project here, not that one. This one here. And I have a desktop client here. So I'm just going to open this in Windows Explorer, go to my bin folder, move this up. So now I have a desktop client. So you can see that client number just went up. So now I have 3 clients. This is a WPF client. So rather than using JavaScript, we have a .NET client in this case. And so if I move this around, you can see it's moving around and all of them over here. And it looks like I've broken something just by talking to you while I was doing that. That's fine. So I have the 3 going on now, and we've got 2 different types of clients. Quick look at that client so you can see the API that's involved. Let's go to the desktop. Let's go to my main window here. It's a very simple canvas object. Who's done XAML here? Who knows? Oh, yeah, well, a lot of people. Okay. So let's have a look at the code behind here. It's pretty simple. On the main window constructor, I just call this thing called Go. All Go does is new up an instance of the hub connection. So this is the .NET equivalent of that $connection move shape that we had before. So I new up a hub connection. I tell it to create a proxy for my move shape hub. So we don't have that magic proxy generation like we do in JavaScript because this is .NET. It's a little bit harder to do that type of stuff. So what you have to do in this case is actually say, go ahead and create me a proxy that maps to this fully qualified type name on the server. And so that's my client-side hub here. And then what I'm saying here is say, well, when the shape moved invocation message is sent, go ahead and run this function, this lambda, to represent being called on that method. So again, this is this is the equivalent to what I did with $extend before, where I added the shape moved function to my JavaScript hub, except this time I'm doing it in a generic, strongly typed fashion because it's .NET. Other than that, it's very, very similar. There's a little bit of a WPFism in here. I have to dispatch the calls from background threads back onto the UI because SignalR is async from top to bottom. The entire framework is written async using the task parallel library that was in .NET 4. And so all of our events are asynchronous, and everything always happens from some background thread, generally. Because most of the time the connection is idle waiting for something to happen. We don't want to be using a thread on the server when that's taking place. So when that's happening, I'm going ahead and just setting the shape here. I have my on-client count change, which is the method that gets called when someone connects or disconnects and changes that number that's shown in the top right-hand corner. Once I've set up those methods on my hub, I then go ahead and start the connection, again, just like I did in my browser before. And then once the connection has started, again, that's asynchronous. I'm using the new await keyword that's in C# 5, part of .NET 4.5 and Visual Studio 11, to asynchronously wait for that start method to finish running. And then once that's happened, it's going to go ahead and add the draggable behavior to that shape. Again, exactly the same thing that I did in the jQuery client, except I wrote a draggable extension for WPF that's very, very rudimentary and basic. Okay. Okay, so let's go back. I was going to show you something here. So, file blue, on client change. Okay, so client tracking. How do we actually do this client tracking? Let's have a look at the hub. Oops, now that I've changed it a bit. And look at what's slightly different. So I have my moose-shaped hub as it was before, it derives from hub. This time I'm implementing 2 extra interfaces. I'm implementing the iConnect interface and the iDisconnect interface. If you implement these 2 interfaces on your hub, SignalR will call you whenever a connection connects to the hub and then whenever one disconnects. This is what you then use to track what people are currently connected to your application. Now, every connection gets a unique ID. You can plug in your own ID provider. By default, the ID will just be a GUID, so it's pretty much guaranteed to be unique across the universe. And our recommendation is you just leave that alone. Some people like to change the connection ID to be the same as the username or something like that. You do run into issues doing that, in that if you have multiple tabs open, for instance, you now have 2 connections to the server with the same ID. So perhaps you would want to use a combination of username and then some other unique number. For me, I think a GUID is absolutely fine because ultimately what you have to do is map an individual connection to a user in the context of your application, okay? When you're using a connection API, a connection level API, it's just something that you have to do. The connection intrinsically has no identity. It just has an ID that represents that connection at that point in time. If you hit F5 in your browser, that connection goes away, you now get a new connection with a completely different ID. So I handle the connect event, and then what I'm doing here is I'm just using a static concurrent dictionary. Who's ever used the concurrent classes in .NET, okay? So these live in the system.collections.concurrent namespace. There's a bunch of concurrent safe or thread-safe collections you can use here. In this case, I'm just using a dictionary because it's the easiest one to use. And I'm just going to store every connection ID that's currently connected to my application as the key in this dictionary. I don't care about the value in this dictionary. I'm just abusing a dictionary so I can store it in a concurrent and thread-safe manner. So when the connect event is raised and this connect method is called, I'm just going to go ahead and call try_add and add the connection ID from the current context into that. And then I'm going to return a task which represents calling client count changed on all of the clients that are currently connected. So someone connects and then I broadcast out to everyone the updated number of the people who are currently connected to this application. Okay, does that make sense? So again, on Reconnect, you can understand that what I'm going to do here is rather than just blindly add it to the list, I'm going to say add or update the list. So if this connection ID doesn't exist in the dictionary, go ahead and add it. If it does, I end up just setting it back to the same value that it was before. Okay, now this is important. Reconnect is that this whole idea of tracking connections when we're doing in a mass sort of scale-out API is very, very difficult to do. And there are still certain circumstances where SignalR may never raise the disconnect event for a particular connection. That's pretty much what we've narrowed it down to now. So if you can imagine the situation where you have 2 web servers, and we'll talk about Scaleout in just a moment. You have 2 web servers, and a client connects to one. And then in the next moment, they then connect to the other server. If they hit F5, then that connection originally only existed on server 1. And now we have a new connection that exists on server 2 for the same user, different connection IDs. Where is the disconnect event fired? If I want to have code that runs when disconnect happens, we need to figure out, well, the disconnect is probably going to take place on server 1, but what if the reconnection was actually a reconnect and not an actual new connection? So imagine the scenario where I connected to server 1, connection ID is 1234, I get a connect event, life is good. That connection goes away for some reason, and then our retry logic kicks in, and we are able to reconnect to server 2 in your farm. It's not a connect event anymore, it's a reconnect. This is why we give you this reconnect event, because at this point what's happened is the client thinks the connection never went away. It's underlying this reconnect logic. But now your application knows that a connect event happened over here, and now a reconnect for a client that was previously connected and is now connected again has happened over here. We give you these hooks so that you can do what makes sense in your application to track where your clients are currently connected and what they're currently doing. So in my case, as I said, all I'm doing is add or update. The other interesting scenario is where you have a single server, clients are connected, the server goes down momentarily, our reconnection logic kicks in the client. So the clients will just keep retrying indefinitely until they can reconnect to the server. The server comes back up and the clients reconnect, but rather than the server telling them what their connection ID is, which is what happens on Connect, the clients are saying, I'm reconnecting as connection 1234. In that situation, the connect event was never fired for that connection in the scope of that application. Because the application went down, then we rebooted the application. In the case of ASP.NET, a new app domain is spun up. You now have a reconnect event, but never a connect event. So these are things that you have to be wary about when you're dealing with an API that's connection level, but you're actually working at a much higher level of abstraction. I mean, if you've ever done sockets programming, you'll understand the connections are transient. Like they connect, sometimes they go away, sometimes you get a clean disconnect, sometimes you don't. What happens if you just pull the cable out? Well, there's a whole bunch of TCP retry logic that happens. Sometimes it'll time out within 30 seconds. Sometimes it'll take the full 4 minutes. We have the same problem with web servers that are hosting SignalR. As far as disconnect is concerned, the last event here, we do our best to tell you when a client is disconnected in a timely manner. So if I jump out of full screen for a moment and I go back to these clients, let's see if we can demonstrate that. So let's pull up this. I'm going to hit refresh in this and refresh in this. And you'll note that those numbers went up to 5. Now that's because when I hit F5, the connection that was there previously sort of still hangs around for a moment, and then a new connection is created to the server. So I currently have 5 connections. What we're going to see is after 20 or 30 seconds, that number will start to drop again as our disconnect cleanup logic sweeps through and realizes that these connections have now disappeared. So the underlying web server doesn't tell us immediately when a connection goes away. ASP.NET doesn't have that capability in 4.0. In ASP.NET 4.5, there is actually an event in the guise of a disconnect token that will tell you when a client is disconnected, and that actually gets bubbled up from IIS. So you can find out almost immediately when a client gets disconnected. What we have is a background worker that runs in your app domain that every 20 seconds sweeps through all the connections. Again, this is the only place we store state. This state only exists in memory for that node in your web farm so that we can track who is connected and who is disconnected. And after that amount of time, we ask IIS, is this client still connected? And if it is, we then check how long, if it isn't, we then check how long they've been disconnected for. And if that is beyond a certain threshold, we fire the disconnect event and the code can react to that disconnect appropriately. So I don't know how long I'm going to wait here. Eventually this will happen. IIS Express is notorious for not giving us the correct information about people who are connected or disconnect, which makes it really, really hard to do this demo on stage sometimes. The IIS full web server actually does this really, really well. And Cassini doesn't support this at all. So don't run SignalR on Cassini at all. Please use IIS Express if you're doing SignalR development on your box. And if you do any type of performance testing, which I'll talk about in a moment, please always use full IIS. Does anyone know what the connection limit is for full IIS on the Windows client SKU? 10. So one of the biggest things that people fall into when doing SignalR programming is they use IIS on Windows 7 or Windows Vista, and then they say nothing works. I hit F5 3 times, and now everything just came to a halt. Well, that's because IIS is throttled to 10 simultaneous connections when you run full IIS on Windows 7. So use IIS Express. It has no concurrent connection limit whatsoever. You can tweak that. It's like 5,000 by default, and you can tweak it up to whatever number you want it to be. Okay, so that's disconnect and multi-clients using .NET client. So we have other clients as well. If I go back to the source code, I can quickly show you the project here. So the WPF app there was using the SignalR client, which is just the .NET client. We also have a client for Silverlight, which isn't shown in this solution. We have a client for Silverlight. We have a client for Windows Phone 7 and 7.5 or 7.1, whatever it's called. We also have clients that have been contributed by other members of the community, which is fantastic. We have clients for iOS, MonoTouch, MonoDroid. Obviously, we have the JavaScript client that I showed before. How many? Am I forgetting any? I'm working on a .NET Micro Framework client. Anyone done any .NET Micro Framework programming? So it's like programming these type of things, but with .NET. So we're working on a client for that as well, which is kind of fun. And if there is a client technology that you would like a client for that we don't currently support, I encourage you to take a look at what's involved in writing one of those, and please go ahead and help the community do that. Okay, so that's clients. Let's talk about Scaleout. So I've talked a little bit about scaling out this stuff in the guise of a web farm. When we've built SignalR, even though it's still in its early phases, we've always kept the idea of scale-out in mind. When dealing with real-time connections and when dealing with this idea of a persistent connection from the client to the server, scale-out becomes a fair problem. If I have, let's go draw this for you so it's a little bit more obvious. Okay, pull my pen out here. So in a web farm scenario, I'm going to have a server here, and a server here. And if we're talking about persistent connections rather than HTTP request response, I'm going to have a bunch of clients that are connected to this server, a bunch of clients connected to this server, and a bunch of clients connected to that server. But they're all part, logically, of the same application. Okay, so maybe I've got a chat application. I want people who are over here on this server to be able to talk to people over here on this server. Because as far as they're concerned, they're all connecting to the same URL. Obviously, somewhere along here, there is a load balancer that everyone is actually hitting, and those connections are being routed off to specific servers, which then stay open for the life of the SignalR connection. So how do we deal with Scaleout? Now, by default, what happens as SignalR is the message bus, the thing that sits at the back of the SignalR API and knows how to, does the core pub sub. Someone says, I'm listening for messages with these keys. Please call me back when you have messages that satisfy these conditions. The message bus, that lives in memory by default. So we have an in-memory message bus so that everything works beautifully when you're on one box or when you're in one app domain. The in-memory message bus uses a bunch of locking and queuing and concurrent dictionaries and this and that, so it's thread safe, but the whole thing is multi-threaded. Doesn't help us when we start scaling out. So what we need is a different message bus implementation that can be a common backplane to all of these servers. So again, this is no different to how you think about scaling out data in a web application. Now, some of these ideas have changed in the last few years. I mean, traditionally, we always just have a big honking relational database up the back. We have a whole bunch of web nodes at the front. We scale that out horizontally. We scale our database tier linearly up, and that's how we do web scale out. It's not all that different when we talk about doing concurrent connections if you have an API layer like SignalR that gives you these plugin points. So we have a very simple interface, iMessage bus, that you can implement, and we do ship some out of the box, I'll talk about in a moment, so that you can plug in your own backplane technology. And then all of these servers connect to this backplane message bus up here, so that when a message comes in from this client down here, client number 1, this server sends that message up to the message bus, and then these people receive that from the message bus like so, and then place that into the local cache before they then deliver that out to all the waiting connections. Okay? Now we have some logic about keeping that cache refreshed and how we slide stuff out of that cache and obviously and things like that, and we're still working on this. Scale-out support is what's going to be the major feature of the next version of SignalR, 0.5, which we're hoping to get out in the next 4 weeks. So what technologies do we support, or are we planning to support, to implement this back-end message bus scale-out? Who's used Service Bus? Windows Azure Service Bus? Anyone here use that? Okay. So the Service Bus team have released, so this was actually written by the team, not by us. If we go up to the SignalR GitHub repository, and down here we have SignalR.Windows Azure Service Bus. So the Service Bus team has actually contributed a message bus implementation for SignalR that uses the Windows Azure Service Bus pub sub channel implementation, so you can use Service Bus to do that. That's obviously, the great thing about that is that if you're using Windows Azure, that's really, really easy to use. And using Service Bus on Windows Azure got a lot cheaper in the last few months. I think it's like a penny for 10,000 operations against the Service Bus instance now. So you can scale out pretty well using Service Bus. And they do some clever stuff around sharding messages across multiple channels in the Service Bus backplane, so you can distribute this across data centers and all types of wonderful stuff. So in theory, if you architect your application well, you can infinitely scale out an application built on SignalR, assuming that we haven't done anything stupid, and you haven't done anything stupid in your application. Again, the standard rules of scaling out web applications still apply. If your application does nothing, you can scale infinitely. As soon as you do something, you have to worry about how long it takes to do that something when you have lots of people trying to do it at the same time. To give you some indication of the type of load that we can support, I'll hold that for a moment. Let's finish off with the message buses. The other message bus implementation we have right now is for Redis. Who's used Redis? Okay, a bunch of people. So Redis is an in-memory database that has distributed storage and also distributed pub sub. Doesn't really run on Windows. I think you can run it on Windows, but most people run it on Linux. And there's this great service called Redis to Go, which hosts Redis as a service online. So you don't even have to have Redis installed in your data center or wherever your app is being hosted. You can just have Redis be in the cloud and you call out to it. Now, obviously, there's going to be a big latency penalty to pay for doing that, but it will work. And depending on your application's requirements, this may be absolutely fine. Now, for the application I've shown you here where I'm moving a shape on the screen, high latency is going to be a real killer. Now, as I said, the way I've done this isn't particularly efficient. I'm just handling the move, the mouse move event and broadcasting every time that happens. That happens at like 30, 40, 50 times a second. If you've ever done real-time applications where it involve movement, like gaming and stuff like that, you'll understand that generally the accepted message rate for what's considered real-time in that world is up to about 10 messages a second. Beyond that, you just can't scale. How do you broadcast more than 10 messages a second to thousands and thousands of concurrently connected clients? There are plenty of algorithms that exist for giving the illusion of fluid movement when you're only getting 5 to 10 frames a second. Okay, there are lerping and all types of things that you can do. If I was going to write move shape properly, I would investigate how to do that, and I would probably only send a few updates a second, and I would have the client interpolate those so it looks nice and smooth. That's well outside the scope of this talk. So let's quickly look at what it would take to enable Redis in my application. So here's my move shape that's been updated a bit. I'm going to go into my references, manage NuGet packages, and I'm going to search for a new package, which is SignalR.Redis. Here it is. So I'm going to install that. Now, by the way, this is all unreleased, so the code for this is available, but this NuGet package doesn't exist. I just created it for the purposes of this talk. Once 0.5 of SignalR is released, there will be a SignalR Redis package in the live NuGet feed that you'll be able to use, and the API will look very similar to what I'm about to show you. Then what I have is an app start folder in my application. This is nothing special at all. App_start is just a convention that a lot of us are starting to use to represent code that we want to run once when the application starts up. This is equivalent to the old global ASAX application start method. The problem is you can't NuGet in new additions to global ASAX application start because it's already defined in your application. So ASP.NET 4 introduced this idea of assembly level application start. So if I go into my startup class here, you'll see I've got this assembly tag that says pre-application start method. This is an ASP.NET-ism. Go ahead and run the go method on the startup class before the application code runs. So when the application is being booted up, it's going to run this code. So next thing I'm going to do is uncomment this using SignalR.Redis, and then down here, all I have to do to use Redis is go into the SignalR.Global, into our dependency resolver, and then off the dependency resolver, we have a use Redis extension method that was added from the SignalR.Redis namespace. And then the only things required to get Redis running are what server you're connecting to, what port, what's the password, and what event key do you want to use for your pub sub. And then that's it. Now you're using Redis in your application. You can have multiple web nodes running, and you'll be able to get pub sub happening between them. Okay. Now, obviously, that doesn't make my application scale-out friendly. It just makes SignalR scale-out friendly. So if we go back to my hub here, who can tell me what's going to be problematic in the way I've coded this as soon as I start running this on more than one web server? The way I'm counting connections. I'm storing my connections in a static member in this class that's going to exist in every app domain, because statics are scoped to app domains, that I'm running this application in. So if I'm running more than one server, I've now got 2 instances of this static class, and I'm counting connections that come to each of the servers. So one thing you have to be wary of, because as soon as you start scaling out, your state can't be in the web tier anymore, which is why SignalR doesn't store state in the web tier. We have this iMessage bus implementation, so you can plug in the message bus so it can do it across a backplane. So I would have to move this logic into a database table, for instance, or a document database, or whatever it is that you want it to be, and then store my connection tracking in there. Now, for a really good example of an application that does this and does this well, we have Jabber. Who has heard of Jabber? Who knows that there is a Jabber back channel for Codemania? Active right now. Okay, so you can go to the Codemania room on Jabber, and here I am in my talk. So yeah, Shifty is there. He looks like he must be in this room. So this is a IRC-like application written completely on top of SignalR. It's running in Windows Azure, and the source code is open. So you can see the fork me on GitHub up here. You can go to GitHub, you can download the source code, we can make contributions. Has a lot of wonderful, great features. If I go into general chat, dare I, avert your eyes if there's anything, so you can see we have content embedding. So if you just paste a YouTube link in here, then the Jabber knows how to turn a whole bunch of different URLs into embedded content. And we have people who are providing embedded content providers all the time. We do a lot of our support for SignalR in here. So if you have questions about SignalR, come into the Jabber SignalR room, and David Fowler, who's the other developer, and myself will be happy to answer your questions if we're online. We also have some private rooms. So this is the NuGet team using Jabber with a private room as a back channel. So I'll just quickly move off that. So this is This is the back channel that they use to sort of collaborate in real time, because some of the NuGet team don't work at Microsoft anymore. And so they needed a communication mechanism that wasn't tied to Microsoft. And of course, we've got the Codemania one here, so I encourage you to jump into that. So Jabber is a fantastic example of an application that has done its state management correctly so that it can scale out across multiple nodes while maintaining this idea of persistent connections. You can even be connected to Jabber from multiple clients, and it'll synchronize the view in those clients. It actually stores, for my user, I'm logged in as my Twitter user, it'll store a one-to-many relationship of all the connections that are currently active for me, and then if I make an action in one, it'll synchronize that on all the connections, which is kind of cool. So if I change room in one browser, it'll change it in the other. If I use the iOS application, there's actually an iOS application for Jabber in the App Store as of this week, then it'll synchronize that as well, which is kind of nice. Okay, so we've only got a couple of minutes left. Performance, very, very quickly. The first questions I always get is, how do you scale and what's the performance? So in the performance testing that we've done to date on my box at home, which is a 2.5-year-old Core i7-920, that's a first generation Core i7, quad-core hyper-threaded. I have 24 gig of RAM, but this, during the load test, the managed heap size is only 50 megabytes, so ignore that. Simulating 1,000 clients, we're able to get about 35,000 sends per second. So that's the number of broadcasts per second multiplied by the number of clients, the actual number of messages we're sending. That was at 32 bytes. When I upped the message size to 4K, I actually saturated the gigabit NIC on the machine that was emulating all the clients. It was this laptop right here. And I could see a gigabit being used in broadcasting stuff from the server. So it scales very, very well. At the moment, the bottleneck is not CPU. It's actually concurrency in our in-memory message bus, or contention, I should say. And so we're going to do a bunch of work very soon to ensure that we can reduce the locking contention and even get better throughput on there. We do have a load test harness called Flywheel here, which is available on GitHub. So if you want to do load testing, you can run Flywheel up, and it will give you a real-time dashboard of the number of connections that are coming in, how many messages are currently being sent. We have and then we have WCAT profiles, the Web Capacity Analysis tool for Microsoft. We have profiles available for WCAT so that you can generate load for X number of clients, SignalR load, and it'll show up in here as how much load you're actually running. Okay, so to finish off, you can grab, to start out, go up to SignalR.net. From here, you can follow the links off to GitHub, learn how to install it via NuGet, talk to us on the SignalR room on Jabber for any other questions. Thank you for listening today, and I appreciate the time, and I hope you use SignalR and enjoy it.